Okay, so now we're going to look at notes on perimeter area and volume of similar figures. First, we're going to need some definitions and some understanding of a few things. First, define similar figures, and we're going to define similar figures as similar figures are two different figures that have the same shape but are different sizes. So, same shape but different sizes. We also note that similar figures have congruent angles and proportional sides. We've looked at similar objects before with triangles most specifically. And now we're going to look at it with an added dimension. What does proportional mean? Well, proportional means having a constant ratio to another quality. So this concept of a ratio and similarity we're going to use to go through the notes today. First, we want to determine which of the following figures are similar. So in order to do that, we need to kind of understand which objects we're going to compare. For them to be similar figures, they need to have the same shapes. So there's only a couple objects on here that we can even really compare with one another. So that would be step one, is determining which shapes I'm going to compare to which shapes. So the pentagonal pyramid, we're going to compare those two. The square pyramids, we'll compare those two. Then we have four cylinders. In this cylinder, the radius is larger than the height. And that's the same in this one. So we're going to compare those two. And then in this one, the height is larger than the radius. So we'll compare those two. Now, I'm not saying that these are similar yet. We're just saying these are the ones that we are going to compare with each other based on our definition of the word similar. Okay, same shape. So now to compare the two, what we want to do is we want to take a look and see if the ratio from this height of this cylinder to this height of this cylinder is proportional to the radius this radius compared to this radius. So if we do that, easiest way to do it is probably in your calculator. So if we take 42, and I'm going to use my fraction button, and I'm going to put 42 over 36 and see what I get. I get 7 over 6. I'm going to take 56 over 48 and see what I get there. And I get the same proportion. So I can say yes, that these two are proportional. Okay? That those two are similar shapes because the ratio between their sides is the same. Go ahead and take a second, pause the video, see if you can do the same for the other shapes, and then unpause it and we'll check your answers. Okay, so coming back, we see that the square pyramids, they had the same ratio also, 21 to 49 and 21 to 49. That one was kind of easy. Here, 28 over 70 does not equal 12 over 27, so those two were not proportional. And here 100 over 40 does not equal 77 over 28. So the ratios weren't the same for all the sides. So our proportional or our similar shapes, similar figures in this were these two cylinders here and then these two pyramids here. If two figures are similar with a ratio of A to B, then the ratio of the perimeter is, well, the perimeter is the same as the length. So it says if two figures are similar with a ratio of A to B, then the ratio of the perimeter is also just A to B. Okay, let's change the color there so we can make sure we see. If the ratio of the area, if the ratio of the perimeter is A to B, then the ratio of the area, well, we know that to find area, we square the sides. So it's A squared to B squared. All right. Now let's kind of put this into practice. If two figures have a ratio of 3 to 4, what's the ratio of the perimeter? Well, we just said that the ratio of the perimeter is the same as their similarity ratio. So that's got to be 3 to 4. And then really simply, to find the ratio of the area, we're going to take each of these numbers and square them. So 3 squared is 9, and 4 squared is 16. So the ratio of their areas would be 9 to 16. Easy enough, relatively simple, making sure that we square each number. Not multiply it by 2, but square each number. Let's take a look at the next page. This is where we can actually have some practice problems with these. The area of a regular octagon, regular meaning that all the sides and angles are congruent. So the area of that shape is 45 centimeters squared. What's the area of a regular octagon with sides 6 times as large? You need to do what your teacher tells you to do, but I'm going to tell you a really simple way to set these problems up is if I just label or list out the ratios that I'm going to use. I'm going to use a to b and a squared to b squared. Okay? I'm going to list those out, and then I need to figure out what are those ratios. Well, let's see. We know that in the problem it says what is the area of a regular octagon with sides 6 times as large. So the sides, let's make this, let's say blue. So the sides have a ratio of 1 to 6. Okay? Well, then what would the ratio of the areas be? Well, if the sides are 1 to 6, then to find the ratio of the areas, we just square both. Okay? So 1 squared is 1, and 6 squared is 36. So now we know the ratio of the areas. And the way we use that now is we say the octagon we have is 45 centimeters squared in area. There's a larger octagon that we're looking for. We don't know what that is. We can set that equal to the proportional, the ratio of the areas, because they're proportional to one another. So we have 1 over 36, small area to large area, small area to large area. Then your calculator, you're going to do 45 times 36 divided by 1, which we know is itself. And so we get x equals 1,620 centimeters squared. That's a huge jump, I know, but you got to think about it. We're finding area, so we're making each side 6 times as large. We're not multiplying 45 times 6. We're making the parts 6 times as long, which makes the area 36 times bigger. Take a second and see if you can figure out the same thing, or actually, I'm sorry. This next problem is different. We're going to work backwards now. Okay? We have two trapezoids that have areas of 847. I'm just going to copy this and bring it down. 847 and 700. Okay, 847 and 700. And that's their area. It says right here, two trapezoids have areas of 847 and 700. So I'm going to put that ratio here, 847 and 700. Now it wants us to go backwards and find the perimeter ratio this time. Our first instinct is probably to just take the square root of 847, but what you'll find out very quickly is that 847 is not a perfect square. Okay, it's 11 times the square root of 7, or 29.1, depending on what your calculator does for you. What I have to do with these kind of problems is I need to first check, does 847 and 700, does that reduce at all? And it turns out in this case it does. And I can figure that out by putting 847 and using my fraction button and putting 700 in. And when I simplify that, I get 121 to 100. Well, those are two perfect squares that we probably recognize. This ratio is a fraction, and we can simplify it to 121 times 100. And then we can take the square root of both of those. The square root of 121 is 11, and the square root of 100 is 10. So the perimeter ratio is this. That's your answer here. It's just that simple. Your answer is 11 to 10. That's all you got to do. Because on this problem, we were just finding the ratio. Let's take a look at the next page. Two more example problems here. We have the widths of two similar rectangles. Rectangles are 3 and 20. What is the ratio of the perimeters? Well, the perimeter ratio and the width ratio are the same. So I'm going to use my a to b and a squared to b squared again. A to b would just be 3 to 20. Okay, the ratio of perimeter is the same as the ratio of the lengths or the widths. And then to find the ratio of the areas, I'm just going to square, not multiply by 2. I'm going to square each of those numbers, and I get 9 to 400. All right. Take a look at this problem here. Find the ratios of the circumferences and of the areas of the small circle to the larger one. Well, we have radii. Okay, we have 6x and 8x. Okay, so 6x to 8x. Well, that can be reduced. I can divide both of these by 2x, and I get 3 to 4. That's the circumference. Then for area, I just square each one. Okay, I just square each one. What we just found was our a to b, and then a squared to b squared would really simply be 3 squared, which is 9, and 4 squared, which is 16. So the answer here is D. Also important to know that that looks a lot like A. Some of you may have guessed A, but just important when reading the question, it says of the small circle to the large one. So we're going small to large. So 9 to 16 is the correct answer. Here it says if the ratio of the sides of two similar figures is A to B, then the ratio of the surface area is, well, we've been using that already. We know that the ratio of the surface area, and let's change colors here again so you can see. The ratio of the surface area is A squared to B squared. And that didn't change colors. There we go. Is A squared to B squared. But we're also going to look at this in terms of volume. Okay, volume we know are objects cubed. So really simply here, the ratio is A cubed to B cubed. The ratio of volumes is A cubed to B cubed. Okay. So that's we're going to use that setup. Okay, that setup for more problems that we're going to work with here. So, for example, this first one, it says the areas of corresponding faces. It's really important to notice what they give to us. And each time, we have a different starting point potentially. So they're giving us the areas. I still think that it's good practice when doing these problems. If it says volume, go ahead and immediately set this up so that you have all of your ratios. So we have A to B. We have A squared to B squared. And we have A cubed to B cubed. Because then you can just go in and kind of fill in the information that you're given. So let's take a look at this one. It says the areas of corresponding faces of two similar pentagonal prisms are 81 and 144. Well, I know area is squared. It's also helpful to sometimes use that 2 here is the same as that 2 there. So I have 81 to 144. And it wants to know what's the ratio of the corresponding side lengths, so I'm going to need to find A to B, of the perimeters, which is also A to B, and of the volumes, which is A cubed to B cubed. Now, it's important, even though we recognize probably most of us pretty quickly that this is 9 and 12 when we take the square root, we still need to check and see if that'll reduce, which on this one it does. 81 over 144 is actually 9 over 16, so we always want to reduce first. That's really key to these problems. Now, the similarity ratio for side length and perimeter is the square root of 9 and the square root of 16. Okay, because we're going backwards. So that's 3 and 4. And then the ratio of the volumes is, it's not easy, but you have to remember just start with A to B and cube it. So to go from A to A cubed, just cube 9. That's 3 times 3 times 3, which is 27. And then 4 times 4 times 4, which is 64. So our answers for side length and perimeter, 3 to 4, and for volume, it was 27 to 64. There are 4 more practice problems, 2 on this page and 2 on the next. I'm going to recommend that you pause the video. I'll have the answers posted when you're done, and then unpause the video, and it'll go through the answers for you. And if you have questions on those problems, feel free to talk to your teacher. All the work will be shown, but those are problems that if you need further assistance on, please ask your teacher in class. I'm going to pause now. You should pause now, do these problems, and then come back and check them. Here are the solutions to those problems. Here are the answers for this page.